Hello, we're here with Daniel Povey, and this is a paper about FastEmit, and this is the implementation done by Kang Wei. And our first question is, what is FastEmit?
Okay, so FastEmit is a method from Google to solve a certain problem with rnnt and similar streaming models, although I think it's specific to rnnt. So the problem is that if you train a model in streaming mode, which basically means you limit how much future context it can see, the model would have a tendency to delay outputting symbols until it's sure what they are. So the idea is that if you're transcribing what someone is saying, you're not going to type every word as they say it, because it's not always going to be clear immediately what the word is. So for an automatic transcription, there's a kind of compromise between accuracy and latency. So FastEmit is a certain method from Google to solve it. Basically, what the method consists of is inside some part of the rnnt kind of loss function, there are some gradients, and they kind of slightly scale up one of the gradients. Now, in my opinion, the method doesn't quite make sense theoretically. But basically, we ended up implementing something a little bit different. It turned out not, that I was able to come up with a justification with. I don't believe FastEmit really quite has a proper justification. Our method is just a little bit better than FastEmit. It's not like a big difference. I think the reason this pull request is not for merge is that we ended up merging our method and not FastEmit. I don't recall exactly what we called it in the code. It's probably something like delayed penalty, something like that. But anyway, it does solve the problem of delayed output labels for rnnt. Yeah, so I don't think the paper that we have on this might not be available online yet. I'm not sure whether I don't remember whether we published it already or we're going to publish it. Can you go back to that pull request and click on the archive link? Is that archive link the Google paper? Or is that, yeah, that looks like the Google paper. Okay, so we have a different paper. You might be able to find it on archive. It's not super important because I basically just described what's in it. Yeah.
Okay, our second question is, what is fast rnnt?
Oh yeah, so fast rnnt is actually kind of unrelated to FastEmit. It's not related to delay penalization. It's just a fast implementation of the rnnt loss function, because the rnnt loss function basically involves a kind of recursion on a two-dimensional grid where each element depends on the element below and the element to the left. So if you just implement that naively in something like Torch, it's a little bit slow. So various people have done accelerated implementations, and fast rnnt is one of them. Now, I believe that for the most part, we're not actually using fast rnnt, but we're using something that we implemented in K2 itself in our kind of backend, which is a different method that does pruning. So basically, even if you use fast rnnt, the rnnt computation is going to use a lot of memory, because for each point in that quadratic grid, you basically have to evaluate a couple layers of a feed-forward neural net. So the amount of memory is quite a lot. So the way pruned rnnt works is we work out which parts of that grid are actually used, because not all of the grid contributes much to the total loss function. There's a kind of a diagonal-ish part of that grid that does contribute. So the way the pruned rnnt works is we use a simpler version of the output layer that's just a dot product to compute that grid and work out which are the important parts on it, and then we only evaluate the full rnnt output network on those parts of it. So we call that pruned rnnt in K2. Yeah, so let's ignore question 3. We already went through that, because delay penalty is basically what we're calling, it's our version of FastEmit. The reason we add FastEmit question 4, that's just to avoid too much latency in the output.
And why are we combining fast rnnt and FastEmit?
Can you click on that? What is this? Oh, I think this is just I think this is a question that might not be very well formed, because basically they're kind of unrelated things. And I think that rnnt repository, I think we must have copied it in order to make some fix or some change, but in the end we're not really using this fast rnnt module or project. Instead, we're using something inside K2 that we call pruned rnnt. Yeah.
Okay.
So bye.
Bye-bye.